Hi, everyone. I can sort of see you all, but not exactly, so this is kind of strange, but hi, audience. So today we're going to be talking about Kubernetes operators with Java, obviously, and a bit of Spring Boot. The Slido QR code, theoretically, is that one for asking any questions that you might end up having that we'll go over at the end of this. So, hi, I'm Tiffany Jernigan. I'm a developer advocate, I guess, currently just for myself. If you're hiring for DevRel, please let me know. That's my website, and if you still use Twitter or X, and then LinkedIn.
Yeah, and I'm Ties van der Ven. I'm from the Netherlands, working for a company called Eleander, which is a Dutch power grid operator. That may not seem like a typical software company, but in practice we have about 200 teams and 1,200 developers working there, building mostly in-house software, because it turns out commercial parties don't really build software to maintain power networks. And with the whole energy transition, we need to have a bunch of software. So my job there is software quality expert, where I try to help the whole company improve the code quality, which is kind of a cool job. And I get to call myself expert, which is a nice boon. So my background is in software engineering, mostly Java and Kotlin. Also dipped a bit into Scala, because I kind of like functional programming. And what I'm really passionate about is figuring out underlying concepts and underlying problems, and then sharing knowledge about them. So that's what we're going to talk about today, the underlying concept of Kubernetes operators. So we're going to talk a bit about what an operator is, how the Kubernetes works on the conceptual level mostly. We're going to show off some custom operators, and in the end, indeed, we'll build our very own operator using Java and Spring. So what's an operator? Well, in the old days, when you wanted to call someone, and we didn't have those fancy cell phones yet, you had to go to the wall where the phone was hanging, you had to pick it up, and you couldn't actually directly call someone. You first had to call the phone center, and there an operator would take your call, ask you who you wanted to be connected with, and then physically pull a plug and connect you to the other person. Well, that's where the name operator comes from. It's someone who takes calls, and based on those calls, do manual actions. And we also still see this a bit in software engineering. During my time as a consultant, I also worked at a company where I finally finished this nice product. Like, I worked a few weeks on it, so I had this jar, and I wanted to deploy it, but I wasn't allowed to do so. I had to call another team because they were the only ones allowed to do deployment. So basically, there was another operator in between. So luckily, these days, we tend not to have that anymore. These days, we have Kubernetes.
So now that I can kind of see people, since my eyes have adjusted, I guess, who here has used Kubernetes before? Okay, so maybe like 2/3 of the room. Okay, so then you probably know that there is a bunch of YAML involved when you're dealing with Kubernetes. So at a very high level, basically Kubernetes is effectively a giant YAML database. So it also just happens to run your containers as pods as well. So within Kubernetes, you have a bunch of controllers that are running, and these basically are behaving as these operators. So instead of going and calling up some center, and in that specific case, a raccoon, because raccoons are cute, at least I think they are, instead you're passing some sort of YAML over to Kubernetes. And then basically the controller then basically checks to see, hey, what is the state that you want to be in, and tries getting you to that state. So to give like a real world example, basically here is like a thermostat. So if you're staying here in a hotel room, for instance, or if you ever have stayed in one, or even at your house, etc., you would have whatever your current temperature is. And so say if this was what I had when I was over in Istanbul, where the room was 24 degrees Celsius, and trying to basically continually monitor it and get it to your desired state. And it's just a continuous loop that just keeps happening over and over again. And even after you get to your state, it will still be checking that, because it could end up becoming off again, and then your AC or your heater may need to go on again. So this is basically how our controllers end up working. So within Kubernetes, there are actually a number of built-in controllers. you may not have been thinking about it, but say if you created some sort of deployment, if you created some sort of job, if you created a daemon set, all of these things have a controller that is causing, like running behind it where it's monitoring and checking, or say if you have your replica set, you've created a deployment and you're like, I want to have 3 replicas. Something needs to go and check how many you have and then get it to the state that you want to be at various points in time. Say a pod ends up dying, you still need to be at that. Say if you want 3, you still have to be at that state.
So how exactly do these controllers work? Well, it all starts with, again, YAML. Sending YAML to the Kubernetes API. You can usually do this by using the kubectl command line tool, but there are a bunch of other ways as well, like if you used like Helm charts or customize or something. In the end, no matter what you're using, you're sending YAML to the Kubernetes API. So what's in the YAML that we're sending? Well, here we have some YAML for cron job, and there's a bunch of fields. The first being the API version, which consists of 2 parts, the batch and the v1. The batch here is the group ID. This is basically the API ID that you're using. And v1 is the versioning of it. Then we see a kind, which is cron job. And Kubernetes uses these 3 parameters to decide which controller should handle this YAML. So it's a combination of group ID, version, and the kind. Then we have some metadata. The metadata is there to store things in etcd, the database of Kubernetes. And then we have the spec, which contains a specific configuration for our controller, in our case, the cron job. So what happens when we send the YAML to the Kubernetes API? The Kubernetes API, you can basically see it as a CRUD service. It just takes some YAML and stores it in etcd, the database. In the cluster, we have a number of controllers running. And these controllers also query the Kubernetes API and to see if there's anything that needs to be updated. So in our case, after we send this, the cron job controller will see that we send some YAML to it, and the cluster is no longer in the desired state. So it needs to create a cron job. If that fails for whatever reason, that's okay. Because we have this reconciliation loop, which continuously checks, is the cluster now in the correct state? If something failed, therefore it's not in the correct state, and therefore it will automatically try again. So we basically have automatic retry. So how does the cron job controller actually does its job? Well, for me, this was the biggest insight I got when researching this topic. Because it turns out most controllers actually don't do a lot. Most controllers offload basically all the work to another operator. So they're just basically calling someone else, can you do this job for me? So the cron job controller basically only does scheduling. As in, something needs to happen at a certain point in time. And when that point in time reached, it just sends YAML to the Kubernetes API, which is exactly the same YAML as you would send through kubectl to create a job. The job controller basically doesn't do much more than send YAML to the Kubernetes API to the pod controller to create a pod. So every controller basically only does one thing and offloads the other work to other operators or controllers. And that's why we call this operator chaining. And this, in my opinion, is what makes Kubernetes so powerful. Because Kubernetes consists of tons of tiny building blocks which all build on each other. And in programming, we call something like this function composition. And this is a very powerful thing, because that means it's incredibly simple, it's easy to use, but it also means it's very easy to extend. So we can easily create our own custom operators using these building blocks.
So by default, you have those built-in ones with Kubernetes. Maybe that does exactly what you need. Maybe it is not exactly what you need. Maybe you need something else. So the first thing you might end up doing is going and looking around somewhere, maybe on the internet, on Google, Bing, whatever it might be, to see what else is already out there. So there's a bunch of companies and individuals that have created their own custom controllers and operators. Basically, you could go to, say, the operatorhub.io, and you can see a bunch of the different ones that are out there. So for instance, if you've heard of Argo, so Argo is an operator that basically, when you deploy it, it pays attention to some sort of Git repository and then deploys things based on that. So then you also have things like a Postgres operator, which then will go and create a database and put your password in a config map for you. There's also external secrets operator. Basically, there's a bunch of different operators that are already out there, and it's also a cool way to learn how to maybe go and create your own at some point, a bunch of different languages. So why may you want to actually go and create your own operator? So the first question you might have is, well, what is the functionality that I need? Okay, so based on that, can I do whatever this is in Kubernetes already? Is whatever I need already there? And if not, okay, so then the question is basically, is there one that is already out there? Has someone already created this thing I need? Okay, maybe there is or isn't. And if it already exists, then that's just things that you don't need to end up doing yourself. There's no point in doing the exact same thing that someone else has already done, unless you don't like the way they did it, I guess. So then basically, in the end result, maybe there's something that you specifically have to go and create your own operator for. Maybe it's just a specific functionality that your company or you specifically need that isn't already out there. Or maybe you're doing something that is proprietary. So let's talk a bit about some more reasons why you might want to write your own operator.
So the biggest reason why you would write your own is basically automating complex tasks for teams. To give a good example for that, my company, Alliander, we made our own operator. This is mostly done for authentication workflow. And for this authentication workflow, we needed to have several deployments done, several config maps, and they all needed to be linked together in the correct way. And if either some things were forgotten to be deployed or the configuration wouldn't be correct, it would either wouldn't work or it wouldn't be secure. So we basically had two options. We either ask 200 teams to all make sure the pipelines are fully correct, or we try to more enable the teams by building our very own operator, which does it for them. Because the operator will do all these things consistently. And now the only thing the teams have to do is send the YAML to that operator for their specific team. So they only basically need to supply a team name, and the operator does all the work for them. And this way, our solution suddenly scaled towards 200 teams. So operators can be used for these purposes, and it's a very powerful tool at that. Another good reason is things like credential management. If, for example, within that authentication flow, you need to create a user in Active Directory or something. Well, that means you have to have credentials to create that user there. So you have to have write permissions, which are quite heavy permissions for a system that you rather don't want everyone to have credentials for. So again, you could have 200 teams have access to these credentials, but that basically means that you're just waiting for something to go wrong, too many users get created, maybe users get deleted, or credentials can get leaked. So you don't want that stuff. So one way to abstract that is, again, by building an operator. This way, the operator and the team building the operator have access to the credentials, but all other teams in your organization can only send YAML to that operator. Basically, you create an abstraction that makes sure that credentials can't leak, and that teams can only do one specific thing, but the thing that the operator allows them to do. Of course, when creating operators, my company also encountered some pitfalls. One of the things we noticed, especially with external secrets operator, sometimes operators can get out of sync. So an operator needs to look at the current state of the cluster and needs to figure out if the state is still in the correct state, or if the cluster is still in the correct state. But if it, for some reason, either misses an event or it's watching some resources outside of the cluster, yeah, then it can get out of sync with the real state. So the nice thing about this is it's not that difficult to solve. I don't know if you ever watch the IT crowd here, but you can just try to turn them off and on again. And when it's turned on again, it will sync again with the cluster and everything is correct. So restarting your operators now and then might be a good idea. And the second thing is about ownership. Like every resource created in Kubernetes, like a pod or a job or a cron job or anything, should be owned by one specific operator, if possible. Because you can imagine, if multiple operators start to operate on the same resource, weird stuff can happen. Basically, in software engineering, the same is with multi-threaded programming. if multiple threads are handling the same bit of data, yeah, things can go wrong. So you want to be careful with that. And a good trick to get around this stuff is using the operator chaining that we talked about before. That way you can make sure that all bits are owned by a single operator. So to build your own operator, there are a bunch of things you can do. There are a bunch of frameworks or libraries out there that can help you specifically build operators. These are just a few examples. There are quite a few more. We're not going to use any of those today. We're going to go for the other approach, just use a REST client. Because most of the things operators do is just talk to the Kubernetes API, which is just a REST call. So any language that can do a REST call can basically become an operator. So to make our lives a bit easier, we actually are going to use the Kubernetes client. It just has a bunch of built-in things that will make it easier for us. It's also supported by a bunch of languages. These are the officially supported languages for the Kubernetes API client. There are also a whole bunch of unofficial, of community-supported languages. So we're doing this in Java and Spring, but you can literally do this in any language that has a REST client.
Okay, so let's talk a little bit about what we are actually going to do. Since this isn't just slides, we're actually going to demo things. So the operator that we're creating is going to be pretty basic because there's only so much time. So there will be a deployment that is running Nginx. I assume most people have done something with Nginx at some point. You get a web page that says something along the lines of welcome to Nginx. But we aren't going to have it say that. Instead, we are going to have a config map. And in that config map, we can pass in some sort of thing that we're calling a nickname. Here, we're just having it as Spring, so then it'll say hello, and then whatever is in that config map. So to kind of look at it at a different way, so we are creating this thing called a foo. Maybe that you have some other name. Maybe it's something that exists that was created for Kubernetes, like a deployment, et cetera. So we have this thing called a foo. This foo will go and create a deployment. And then that deployment will then create replica, which creates pods. And then we also have the config map as well. So one of the things that we need is to have a custom resource definition. Basically, to the way that Kubernetes has the operator pattern, you have your controller and you have your custom resource definition. So then we need our controller. We have our reconciler, which is where the majority of the logic that actually goes and says, hey, what are we creating? Where that will be. We need to have some sort of role bindings because Kubernetes needs to be able to, with our code, it needs to be able to have some way of being like, hey, I can see a foo. What is a foo? Okay, can I get it? Can I list it? Can I be able to do a watch on it? Can I see the deployments that are being created, the config maps? Just basically being able to do things with it and see what's there using role-based access control. And then we also need to go and create a deployment that will be starting up our controller. So let's hope the internet works and try demoing things. Okay, cool. I guess after typing things happen, I will verify if people can see the text or not. Okay, so the first thing that we need to go and do is create our custom resource definition. So we have this lovely YAML. Who here has not had to touch YAML when dealing with Kubernetes? Okay, cool. That's what I thought. All right, so we need to have some sort of name. And this needs to be some sort of valid DNS subdomain name. So for us, we are calling it foos.spring.io. This spring.io is also our group. We have our names. So we have what the kind is. We're just calling it a foo. There is a plural, which is foos. And then we also have the singular. And then also whether it is, for this, it is specifically it's namespaced. Then what version is it? So you may have seen something like apps v1, batch v1, etc. So we need to have a version as well. And then there is this open API v3 schema that we are using to define what we actually care about here. So if we jump down to here, there's this thing called a nickname. It's pretty basic. It's literally just a little bit of text. So it's just the nickname of what our foo is. Again, the example that we specifically have is just using Spring. So with using YAML and Kubernetes, you most likely have interface with using kubectl. So what we're just going to do is we're going to go and create that. So based on this, can everyone actually read the text? All right, I'm going to assume that's a yes because I'm not hearing anyone yelling at me. OK, so when we have that, we can go and actually look at our CRDs. So if we take a look, we can see our foos.spring.io. Who here has heard of kubectl explain before? OK, I don't see hands, but so if you have a specific type of resource, which you can find out where it's located if you do like kubectl API resources, you can see what the different resources are. But basically, you can do an explain on any sort of resource. You can get a bunch of information on it. So like you could do a kubectl explain on deployment, and then you can go down and do a kubectl explain on deployment.spec, et cetera. And you can also do -- recursive and get all the fields that you can end up setting there, which is super useful for some of the certifications there instead of having to go look it up. But if we look here, we can just see that we have our one field, which is just our nickname. All right, so now that we have that, we can actually go and create our first resource. So this is the point that you're probably used to if you are going and creating, say, a pod, a deployment, or whatever else there is. This is the point that you're at. So we have our API version. We have our spring.io/v1. We have our kind, which we're just calling a foo. We have a name of it for our new foo, and then just passing in the nickname, which we have as Spring. We could change that to something else. So then we need to go and actually create that. So right now, Kubernetes knows about our custom resource definition and knows about our foo, but it doesn't specifically know things like, hey, I want to go and create a deployment, and I want to create a config map. So those are things that we eventually have to get to. OK, so who here has used Spring Boot before? OK, cool. So chances are, when you were starting off, you probably were using start.spring.io. If you haven't heard of it, maybe listen to one of Josh's talks. Probably in the first 5 minutes, he talks about how it's his second favorite place on the internet. So this is where we basically need to start there. So if you haven't seen it before, it's the Spring initializer. You can choose whether you want to use Gradle, whether you want to use Maven, whether you want to use Java, Kotlin, or Groovy. Then you can choose, there's a bunch of different dependencies you can add. You can take a look at what file's already there and pull this down instead of having to start from scratch, which is super helpful. So instead of doing that, we threw everything into a zip file, so that way it's already there and doesn't take up a bunch of time. So there's a bunch of dependencies that are already there based on what got set in, if we take a look again here as to the dependencies that are added. It doesn't have the Kubernetes Java client there, so we have one that we need to add that to our dependencies for the Spring integration for that. The other ones, the Spring Boot Starter and the Spring Boot Starter test, are things that already come there. So we have a bunch of YAML right now. We need to be able to have some way to be able to see interact with these types of resources using Java. So things like deployments, et cetera, they're already known about, but it doesn't know anything about our foo. So there is this tool that basically creates a kind cluster and creates models based on your YAML. And you can go and look that up. We'll show a link at the end that has a bunch of this stuff there. And instead of doing that, again, we just threw everything into a zip file. So if we go and take a look here, you can kind of tell it was generated. It basically tells you at the top there. So we have a few files. We have our v1 foo, we have our v1 foo list, and our v1 foo spec. We can see a bunch of the things that we saw in our YAML. We have a kind, we have a metadata, we have spec, we have status. If we go and take a look at the v1 foo spec, then we can actually go and specifically see that we have our nickname here, which is the one thing that we created that we actually kind of care about.
So then it's time to actually start creating our controller. So let's do that. We'll start with creating our controller. And for that, we need to have access to a few beans, two of which are part of our shared index informer, and we need a reconciler. So this is a good part to talk a bit about what an informer is. So as I told before, in the Kubernetes cluster, there are a bunch of controllers running. There could be quite a few of them. And it's their responsibility to ask the Kubernetes API if there's any work for them to do. So you may imagine if all the controllers within the cluster are just calling the Kubernetes API in a while true loop to, do you have any more work for me? You're basically effectively DDoSing your own cluster, which isn't a great strategy. So to combat that problem, the Informer was introduced. And you can basically see this as a cache between your service and the Kubernetes API. So the Informer talks to the Kubernetes API, and we talk to the Informer. And this way, the Kubernetes API doesn't get DDoSed. And the nice thing is, when an Informer starts up, it will first look at the current state of the cluster, and then it can create deltas based on the things that are coming from the Kubernetes API. And because of that, our controller can sort of work in an event-based way. So that's what we have to do with an Informer. So for this, we can first start with a controller builder. And this is a class that comes from the library that we're using. It's just an easy builder where we pass the things for our Informer. We pass a reconciler, and we can tell it it's ready when the Informer has synced with the cluster. So our controller shouldn't do anything before the Informer is ready. The default is 16 workers to do things, but we're only going to do one request, so we can only use 2, or we don't need to use more than 2. And then it's time to start our application. So first we register all Informers, so that way they will start running. And then we run our controller, which will start, but it won't actually do anything until the Informers are ready. But this is the basis of just the controller. After that, we need to do some things for the Informer, where the first thing we need to do is create an API client for it. So we get something in here from type API client, and this is one of the, as we can see in the Gradle, this Kubernetes client has a Spring integration. So what does that mean? It basically means there are 3 beans available, which are conditionally loaded, and that's it. So the whole Spring integration bit isn't that exciting. But one of the beans we get is an API client. And the API client basically contains all the information that's needed to talk to the Kubernetes cluster. So what we're going to do for our Informer here is we're basically going to create a wrapper around that API client. That is only that makes sure that we now have a custom client that can talk to one specific resource, namely our foo. So we can see here that we want to have a client that can talk to this specific group, Spring.io, to this specific version, and to our foos. So now we have a client that can specifically talk to the resource that we just created. And then we can create our shared index Informer based on that client that we just created. So this way, our Informer is only listening to our specific resource because it can't access any other resources. And of course, we add some imports for that. And then it's time to start with the real stuff, the reconciler. So this is the thing that does all the actual work. The Kubernetes client, the client library that we're using already has an interface reconciler. And it tells us to override one method, which takes a request and returns a result. So the result has a Boolean parameter. And this is a bit counterintuitive. This basically tells us should we reconcile again. So if anything went wrong, it means we need to reconcile again, which means we would need to return true. Once everything is done and everything is correct, we don't need to reconcile again, so we can return false. So in this case, we reconcile, and everything is okay, so we return false. We will not enter this loop again. So the very first thing we need to do is our request doesn't actually contain everything that was in the YAML that we sent. It only contains those things we need to look the things up. For that, we have a lister, that can talk to our informer. And out of that lister, we can just by key get the resource. So here we have a variable which contains our full resource, which does contain everything that we send to Kubernetes. So the first thing we have to do is check if it's still there, or because it might have been removed in the meantime, or check if the deletion timestamp is there, because someone could have created a resource and then instantly deleted it, which means that our cluster is actually in the correct state right now, because we don't actually have to create this resource. If that's the case, we can just return a result saying false, reconciliation over, the cluster is in a correct state. So we add the dependency to the constructor, and we add some imports. And then it's time to create our first thing, our config map. So we're first going to create a config map, and then we're going to create a deployment. So for a config map, we create a map which has two keys, the first one being the file name of the file that we're going to overwrite. So we're going to overwrite index.html, so the nginx doesn't show the default page. And as content, we're going to give just a title saying hello, and then we get the nickname from the spec. So this is how we introduce our nickname here. And then it's time to create our config map. For this, we can use a V1 config map builder. Again, for all the foo things, we had to generate those because well, that's something that we made. But for everything that's already in Kubernetes, this client already provides objects to talk to the Kubernetes interface with. So, and they have handy builders that allows us to create these objects. So this is basically the same thing as writing your own YAML, but then through the builder API. As you can see, it's a config map with an API version. We set the name, the namespace, and we set an owner reference. So this is what I talked about before, that every resource should be owned by a certain resource. And Kubernetes can use this also for things like deletion. If you delete one thing, then it knows what other things it needs to delete. So we can set the owner reference to be ourselves. We'll have a separate method for that. It's exactly the same. It's a builder for the ownership, and it sets a bunch of values for that and builds in the end. That's not the main thing today. So after this, we have a config map. And of course, add some imports. And then we need to going to apply this to Kubernetes. So the first thing we have to do here is put a try-catch around it, because something could go wrong. Like the Kubernetes API could have a glitch, or we have some network errors, or there could be any reason why creating a config map went wrong. So when any exception occurs, we're first going to log it, and then we're going to return a result, but this time we'll return true, because something went wrong creating a config map. Therefore, the cluster is not in the correct state, so we need to reconcile again. So we'll go back into this loop. But we don't do it directly. We say, well, maybe we should wait 10 seconds. Just in case, like if the Kubernetes API was glitching a bit or whatever, we give it 10 seconds to come back up again, and then we'll try again. So this is our automatic retry mechanism. So in order to create this config map, just like for our for our informer, we needed to create a specific client to talk to that specific resource. We also need to create a client that talks to the resource group of the config map. So we can do kubectl API resources config map, and here we can see the group, which is just v1. And this is because a config map is part of the core API of Kubernetes, and therefore it's one of the few things that doesn't actually have a group. So let's just assume we have an implementation of the core v1 API here. This is a class that comes from the library that we're using, so we don't actually have to write this ourselves, but we'll see how it's created in a second. So we inject that into our class, and we can use that to create our config map. So the very first thing we do is check if the config map already exists. Well, we can do this in a very, very dirty way, but just list all config maps within the namespace. If any of the name matches, then it exists. Otherwise, it doesn't. And when it exists, we replace it, and otherwise we create it. And again, these are just REST calls. So this is equivalent to a put operation, and this is equivalent to a post operation. And this is very important that we actually do this check and do the replacement, because we want this method to be repeatable. As we saw before, it's possible to, we are in a reconciliation loop. So it's possible that something, for example, with the deployment fails, so we'll enter the reconciliation loop again. If that happens, and we wouldn't check if the config map exists, but always try to create a new one, yeah, the Kubernetes API will throw an exception saying, oh, that config map already exists. So what happens then? Then we come into our catch here, which says, oh, we want to reconciliate again in 10 seconds. So 10 seconds later, it comes back here, trying to create a config map, throws an error, and reconciles again. So now we're stuck in an infinite loop. That's not a good thing. So we want all actions within our controller to be repeatable, because that's the whole nature of a reconciliation loop. Things can get repeated. So we made sure our config map is repeatable. And so we add some imports. And now it's time to do the same thing for deployment. Again, we do some error handling to check if anything went wrong. We'll return a new result saying true, we need to reconciliate again. And for a deployment, we could do exactly the same thing as with the config map. There's a standard builder for that, but as you may know, the deployments can get quite big. So we're gonna sort of cheat a bit, and we're gonna just use a YAML template instead. So we have a deployment, which is in groups apps v1, and we have some placeholders for the name and the namespace. And here we see that we want to have an image of Nginx. We'll have the latest version. We want to have 2 replicas running of it. I want to run it on port 80. And this is the important bit, where we basically mount our volume to our config map. So this makes sure that we override the standard index.html page, so it will serve our website instead. So we can just load this deployment YAML from our class path. We could do some fancy YAML templating, or we can just replace all namespace with the correct namespace and replace all names with our name. That should be good enough for now. And we have this nice tool that again comes with the library, which just loads our string into our class. So now we actually have v1 deployment that we can use to send to Kubernetes. So that's nice that that comes all out of the box from our client. So in order to send the deployment YAML to Kubernetes, we need to have a client for that specific group. As we just saw, it lives in the apps v1 API. So in order to do that, we need to add an apps v1 API client to that. And once we have those, we can do exactly the same thing as with the config map. We first check if the deployment exists by just listing them all, and if any name matches, it exists. If so, we'll replace it, and otherwise we'll create it. Again, making the function repeatable. And we add some imports. And so what we have created right now is a reconciliation loop where we first get the full resource we have access to. We check if it's still correct, as in, do we still need to do something? If everything is correct, we'll create a config map. We'll apply a config map. We do some error handling. Then we create a deployment. And if everything went well, then we are done with reconciliation. And this is basically how simple our controller can be. We're just sending 2 requests to Kubernetes to create our own resources. So now we need to create our API clients. Luckily, that's very easy to do. Just like the client we created for Informer, it's just a wrapper around our API client that we can wire. So we do that for the apps v1, and we do that for the core v1. And we create a bean of type reconciler, thus just creating new instance and passing all the things. So now finally our controller should be able to work. And in the end, we can add some imports. And then it's time to actually run our application.
Okay, so yeah, now we have like a little bit of YAML since it's kind of hard to avoid unless you want just a bunch more code. We have a bunch of Java code there, but right now nothing besides our CRD and our foo are actually running. We need to actually go and run our controller too. So one of the first things that we need to do is we need to actually create an image based on this. So who here has heard of cloud native build packs? Okay, a few people. Okay, so who here has heard of a Docker file? Just checking who's still paying attention. Okay, so with the Docker file, you need to start with some sort of base image or Scratch or whatnot, and then you need to go and do like maybe, for instance, an apt-get install or whatever it is based on what system you're using for all the different resources that you need. You need to put your file in a certain place and run it, etc. So with cloud native build packs, instead of having to go and create your own Docker file, you just basically use the build packs. You have your code. It will go and detect what build packs are needed to be used based on what language you're using. So there's build packs for Java, there's build packs for Go, etc. There's a bunch of different ones out there. So based on your code, it will go and create a container image for you. So if you're using, you can use either Maven or Gradle. If you are using Spring Boot, it has this stuff built in. So you can just see that's basically, for instance, Spring Boot, and you have build image. And so you can do that, and you end up having your image created. We just went and did that already, and since it takes a little bit of time, and then put things into a zip file. So if we go actually, and I guess I actually ran that, so it's already running, so there's no point in doing that. But basically, we could go and do that. So if we take a look at our images, it's using Harbor, which is one of the container registries. So we can see that we have our foo controller here. One of the slightly strange things is that it says that was created 44 years ago, which was before Docker was even around. So with having our image, we need it actually be in registry. It's not like if you're just using Docker locally where you can just have your image locally. You need to actually push it up somewhere so that Kubernetes can go and find it. So we're just pushing it to the registry that we have over here. So I guess I should have hit that a little faster based on the internet. But yeah, basically this just is another way to be able to go and create your images and then just make it be a bit faster depending on how you want to go about doing that. And there's some settings that you can change around as well. It's not necessarily just exactly the default of like, here's my code and then just run things depending on what you want to do. Okay, so let's go and take a look at this YAML. So we were talking a bit earlier about role bindings and role-based access control. So this is where we need our controller needs to be able to actually see these resources. So we need to be able to see in the API group spring.io, we need to be able to see our foos. We need to be able to do a get on it. We need to be able to do a list. We need to be able to watch the resource. We also need to be able to do this for the other resources that our foo is creating. So being able to go and look at our config maps and also at our deployments. So then after you have your role, you also need a role binding to attach that to a service account. We're just using the default service account. You could also go and create your own. And then we have our deployment that actually goes and runs our controller. So you can see that is just, we're calling it just foo controller, and it's using the image that we pushed up. So we can go and create that. So then basically you might just assume, okay, here's my deployment, here I'm running my controller. All right, so now let's go and take a look at the resources that it actually ends up creating. So if we do a kubectl get, we can actually do a get now on foos, just like you would do on pods, on deployments, etc. So you can see we're doing a get on our foos, our config map, and deployments. If we take a look here, we can see that we have my first foo, which you may remember from the YAML a little bit ago that we created. We have our config map as well, also for my first foo. And then we also have our deployment as well, which is up and ready. So in order to actually be able to take a look at what is running, we need to have some sort of service if we want anyone else to be able to look at it, for instance. You could do a port forward if you're doing it locally, but if you want anyone else to be able to access it, then you need to do this. We are using an ingress controller for the way that this is set up, so we can just do a kubectl expose on port 80, since that is just the default port for Nginx and where we're running this. And as a result, if we go to the link here, we can just see that basically everything that we went and did, the YAML that we created, our custom resource definition that we ran, the foo that we created, our Java code, resulted in a thing that you can see at the top here that is like the screenshot we had before that goes and basically just says, hello, Spring, and then you could go and make changes to that. But basically, this is just a starting point. This isn't something that, like, yes, we're creating a deployment. Yes, we're creating a config map. Maybe you need to do something like that. But there's a lot more complicated things that you probably will end up wanting to do. But going into something super complicated within a 50-minute time span, especially if people didn't know how any of this stuff worked before, would be a little extreme. And then if we go and take a look back over at the slides. Okay, yeah, so basically all that code, everything that we created is doing that right there. So again, you can see that we have our foo, we have our config map, we have our deployment, and then we have a bunch of pods that are created. We had our custom resource definition, we have our controller and reconciler code, we have those role bindings, and then the deployment that goes and launches that. So if you want to take a look at the code that was up here, instead of trying to do all of it yourself, for instance, that's the QR code that is there. The QR code at the top is just so you don't have to go and, if you actually care enough, to type in our contact info up there. So I guess now it's time to look at questions.
How do you test your operator? Any challenges in writing unit tests for operators? Good point. I actually did that. It's hard to find any information about the unit tests because I think I was the first person to actually do this with the combination of Spring. But I actually wrote an integration test that we're also going to add to, maybe going to add to the repository, which starts up a K3S test container. Then creates our own API client with information to talk to that specific test container. Then it starts up our controller, just using a Spring Boot test. And this way, our controller is run locally, but it talks to the K3S Kubernetes cluster we just created. And then we can just create our custom resource definition there, and then create our own custom resource, and check if the deployment and config map still exist. So it took me half a day, but yes, you can actually write integration tests for this quite well.
And this was the only question, yes?
In that case, thank you for your attention, and have a great conference.